Hello and welcome again to another lecture in DSP. As you can see, we have two types of DSP, the finite impulse response, FIR for short, and the infinite impulse response, IIR. The finite impulse response is non-recursive, and we will look at them first. We can specify any DSP by either its difference equation, its impulse response, its frequency response, or its transfer function. In this video, we are looking at the difference equation and the impulse response. An FIR DSP output depends only on its input. Remember that. That is the classification for an FIR DSP. An IIR DSP, on the other hand, depends on its previous outputs as well as its current inputs. Okay, now suppose we have a difference equation as shown, and we have an input as shown of just three numbers. We use the equation and the input to process our output, which is pretty self-explanatory if you study this slide. The one thing I want you to know, which is very important, is that our output list is longer than our input list. And this is fairly normal with DSPs. Now, what about the impulse response? The impulse response may be obtained directly from the difference equation. When you look at them there, you simply replace the y with h and the x with delta, and the equations are virtually identical except for that small change. We can then compute the response, and here you can see that the response is three numbers long, and we do that by remembering that the delta function shown there is a 1 when n is a 0, or when whatever is in the brackets is a 0, and 0 otherwise. You can go back to previous videos to find out about that. Okay, so what happens now is that we want to convolve this impulse response with the input table xn to produce our output yn for our DSP. And we shall do that now. First, we write out the value of n from 0 to 5 in a sort of spaced format so that we can develop our columns underneath each number. And then we write down our x of n, in which case, if you look back to the previous slides, you will see we have three numbers. And then we write the hn underneath of that, which we've just finished calculating. And now we're ready to process. Notice what I have done on the left-hand side. I have written down the three values of xn, 2, 1, and -2, multiplying the hn, but I've shifted the hn right after each row. So we start with hn, we shift it 1, and then we put another row, and we shift it 2, and we put another row. So how does that work out in practice? Well, as you can see, we've taken the hn values, we've multiplied them by 2, and we've written them down lining up with 0. In the next row, we have written down the hn values, moved one place to the right so that they're starting at 1. N equals 1. So that's the meaning of the n-1 sign. We are right shifting for the h results. Okay, so in the next row now, we have shifted another space and we're starting at 2, and once again we multiply them by -2. So -2 is being used to multiply the 1, 2, and -1, which causes the change in sign. Finally, we add up all the columns, and that gives us our yn values. And as you will see, these yn values are identical to what we had when we used the difference equation. Finally, you'll want to be able to draw a diagram for your DSP, and this is how you diagram your difference equation. As you can see, the n-1, n-2 relate to a time-shifting operation, or a shift of 1 clock pulse, if you want to think of it that way, time delay of 1 clock pulse, whereas the coefficients that are used to multiply the various terms represent linear scaling factors. And then finally, we do some linear summing of all the terms, and we have our y of n. So that's just a graphical description of the difference equation. Finally, we look at the general difference equation for a finite impulse response, DSP, and this shows us that according to the number of terms that we have, m, we can develop any difference equation according to this pattern. Well, that's it. See you in the next video. Thanks for watching. I hope you enjoy the sound. We're now coming through both speakers using our new sound recording techniques. Thanks for watching.